Hey everybody, this is Gregory from Dapp University, and today I have another special guest on the channel. I've got Ken Anderson here, who is the Chief Developer Advocate for Hedera Hashgraph, a project that I've been watching in the decentralized space. And I'm very excited to have Ken here today to talk about Hashgraph. So welcome, Ken.
Hey, thanks for having me.
Awesome. Yeah, we're glad to have you today, Ken. So before we kind of jump in and start, bombarding you with questions, do you want to kind of maybe educate us about, what Hashgraph even is?
Sure. So, Hashgraph is a consensus algorithm. So that's first and foremost. And what I mean by consensus algorithm is it's a mathematical way for multiple parties who may not necessarily trust each other to come to consensus about some state of data. So in this case, we can call it like a database or a ledger. Hashgraph is the mechanism by which all these multiple parties who don't necessarily trust each other come to consensus about the state of that data.
Very cool. So I might try to dig into that a little bit. So,
Sure.
On my channel, I talk a lot about Ethereum and, using Ethereum for decentralized applications. Ethereum has a consensus algorithm. So how would you use an analogy maybe to compare Hashgraph to something like that?
Well, so if we look at how Ethereum and kind of classic, I guess classic being a couple years old here, right?
Sure.
Classic proof of work consensus mechanisms work. The way they do it is they're basically electing a leader to define what's going to go on the next block or the next page in that ledger. And that leader election process is done through a very complicated math problem that the first person who solves it and can prove that they solved it gets to claim the next page in that ledger or claim the next block. So it really is a mechanism for choosing a leader that everybody's going to get behind and say, okay, that person, whatever they say, as long as the transactions came from the transaction pool, and as long as that block mathematically equates, then we're just going to accept that whatever they said is the answer. With Hashgraph, the way it works is that everybody transmits their transactions as fast as possible. And then every node or every server in that network comes to consensus or comes to a mathematical proof of the state of the network independently. In other words, there's no leader selection. The idea is that when one node knows that 2/3 of the rest of the network, how they came to knowledge of a certain transaction, they can actually run a mathematical proof against it and prove that 2/3 of the network is aware of that transaction. And each node independently comes to that consensus, basically. So that's why we talk about asynchronous versus, say, like the traditional Byzantine fault tolerance, meaning that in Byzantine fault tolerance, the idea is how do we prevent bad nodes from corrupting consensus? Asynchronous Byzantine fault tolerance says that every node comes to their own conclusion and all of those results just happen to be identical because of the math. So that's the difference between what we're doing and what Ethereum is doing. And with Ethereum and Bitcoin, for example, we have to have this complicated math problem. And that's actually to slow down the creation of the blocks so we don't get too much forking and too much pruning and that entire process. In our case, what we're basically saying is everybody just blast your transactions as fast as you can, as fast as you can, and everybody's going to come to consensus at approximately the same time, but about the same state and order of the ledger. So there's no slowing down with Hashgraph. The limitation is actually the internet bandwidth.
Cool. So with that kind of limitation in place, what would be, how would that change things for someone who wanted to develop a decentralized application? What would a transaction time be?
Well, I can tell you, we're talking seconds. And our target for the public network, Hedera, is to do it in sub 10 seconds. So we're figuring probably between 5 to 7 seconds maybe for transactions. And again, this depends on transaction size of the network, how many transactions are going through at the same time. But we're shooting for hundreds of thousands of transactions a second with about 5 to 7 seconds of latency. In other words, time to completion on those transactions.
Very cool. So if what kind of things could we build with Hashgraph? Maybe not necessarily opposed to Ethereum. Some things might be like complementary or other blockchain use cases. Like, could you give me an example?
Yeah, so we kind of have to change how we think about distributed ledgers right now. Distributed ledger technology is what I would classify blockchain as. It fits in that category. There's also another group of technologies called directed acyclic graphs, or DAGs,
Sure.
That also fall in the same category. And so there's different ways to solve it. I feel like there's been a real stretch to apply blockchain technology to real-world applications. In my particular experience, I work in a lot of working groups, specifically in telecom, where they're trying to solve a lot of real-world problems, including things like device theft and asset and device management and telephone call data roaming reconciliation, supply chain management, IoT. I mean, you name it. All of these things are real-world applications where you've got a number of parties that don't trust each other, but still want to interact and share data with each other. And they want to be able to trust the mechanism of sharing and not necessarily have to trust each other.
Sure.
And I think anytime you can say, does my application require that multiple parties have to interact where the parties don't trust each other? And as a matter of fact, the parties may even have conflicting interests, but they still should be interacting in some way. You can see this with supply chain management where, at the very edge of the supply chain, you've got retailers. And the retailers may be competing with each other, but they all want to participate with the same distributor or wholesaler or manufacturer, whoever it is that they're dealing with. But they all want to have that same level of trust that their orders are going to get to them and that they're going to get to them intact and that those are the right orders and all of those types of things. So when I think about the solutions that people are thinking of in blockchain, I'll give you an example. In the telecom space, I sat down with a working group and they were like, okay, here's a solution we can do using open source Ethereum. Now imagine if we could do this 10,000 times faster, then we could actually use this. And that's kind of the limitation that we're seeing here. Is it really is a throughput limitation. That's the first point that people come to. The next one is the level of confidence of the finality of the transaction. With Ethereum and Bitcoin, and really with blockchain in general, you never come to 100% consensus on the state of the data, but you approach 100%. So the more confirmations there are, the more blocks that are added to your block, the more sure you are that that chain isn't going to break or isn't going to be pruned in the future. But you never actually reach 100%. You just approach 100%. And we can be practical and say, after 30 blocks, we're just all going to assume that it'll never be changed because it's really, like, for all practical intents and purposes, it's pretty much impossible to fork that. But that's fair enough, but it still isn't 100% consensus. So what we're getting with Hashgraph is we're getting throughput. So we get the speed, hundreds of thousands of transactions a second instead of tens or hundreds, or if you're looking at like Hyperledger or EOS, thousands.
Sure.
We're talking hundreds of thousands of transactions a second. We also get the security component of it because we're not relying on any one leader or any group of elected or round robin leaders to make decisions. It really is every single node coming into an independent conclusion on the consensus state of the data. There is no DDoSing the leader. You can't attack a leader if the entire network is independently coming to the conclusion. And that's really the power of the algorithm. And then also being able to have that 100% finality. When we mathematically can prove that 2/3 of the network has seen this data, and that is good enough, a supermajority is good enough for us to accept that that data is final, that allows us that 1/3 flexibility in case people go offline or become malicious or whatever. They can do whatever they want, but we know 100% that 2/3 of the network has voted on this transaction that it is true, and we can mathematically prove that. That opens up a whole lot of trust in the network. So now we're talking about bank applications and telco applications and healthcare applications, where with blockchain, you can never be 100% sure of the state. You can practically be sure about it, but you couldn't be 100% sure about it.
Sure. So
those are some areas, some of the power that Hashgraph brings. And I just want to restate that. When we talk about speed, hundreds of thousands of transactions a second, we just have to remember that like Ethereum on a good day is doing 20 transactions a second. Sure. And I think even recently I heard Vitalik say something like it's probably closer to like 10 to 12 transactions a second. So we're talking orders of magnitude more throughput here. And if you look at like AT&T's cell data, their cell phone data, their mobile data, they're doing about 90,000 transactions a second on all of AT&T's network for cell phone data, which happens like constantly. Anytime somebody's on a phone, they're transmitting regularly to make sure that they have enough balance to continue with the phone call. It's called CDR, or call data record.
Sure.
those CDRs, 90,000 transactions a second, what AT&T is doing. And we're talking hundreds of thousands of transactions a second. So the possibilities open up very quickly of what could be accomplished here. And then the final thing, which I think is probably one of the coolest, there's a few other cool things on the public network, but on the Hashgraph algorithm side is the ordering. So the fact that your transactions come out of consensus in fair order, meaning it is the median timestamp of when your transaction was received by the network is how we order your transactions. Now you can do order sensitive transaction type projects, where with Ethereum, it's whoever paid the most gets pulled out of the transaction pool and put into the next block. In our case, it's okay. It doesn't matter how much you paid in transaction fees. It's when the network became aware of your transaction is how we calculate your order relative to every other transaction that gets dumped into the network. So now we can do things like exchanges, like a real decentralized exchange.
Sure.
Just we hope that you paid enough gas to get in there faster than the next guy. So it's lots of things that are sensitive to ordering, which is pretty much markets. Anytime we think about markets, there's always a limited or a scarce resource or inventory that you're trying to sell. It really is important who places the order first. So lots of those things. And we'd like to just break it down to, fast, fair, and secure. That's kind of the three terms that we always say. It's really fast, hundreds of thousand transactions. It's fair. You get ordering out of it, fair timestamp, fair access, and it's secure. We've got the asynchronous Byzantine fault tolerance that gives you 100% consensus in a very short period of time.
Very cool. Yeah, thanks for that. That was an excellent explanation. So if I was, going to build a Dapp and I was going to try to use Hashgraph, how would I get started?
That's a great question. So we are in the process of building our public network. We announced it back in March, so it's still relatively new. But we are looking at this summer releasing the APIs and the testnet to the public. And then by the end of the year, we're going to have mainnet up. I would say if you want to get into building dApps, the first answer is stay tuned. The second answer is join our developer channel at hashgraph.com/Discord. If you want to stay tuned, that's probably the best place to stay tuned because that's where we'll be announcing those API docs and the testnet. And that's where we'll be picking people to participate in some of the limited testnets that we're doing as well.
Awesome. Very cool. Yeah, thanks for that information. So also got word that you all have a developer advocate program. Can you tell me about that?
Yeah, so I'm the chief developer advocate, and I've got a number of developer advocates around the world. We've got 2 in Singapore, myself and 1 more here in California, and then we've got 2 in Europe. Our job is basically to make sure that developers have the resources they need to build on the platform. And right now, all of our focus is on Hedera, which is the public network. And so let's just put it this way, the guys that are writing the curriculum, the guys and girls that are writing the curriculum are developer advocates. And so that's what we're doing. We're also building the platforms and the documentation that's going to go along with developers. All of those things are being developed by us. But again, we like to think of ourselves a little bit different than maybe like other people will consider sales evangelists, if you will. Our approach is really in the community. We listen when a developer, and we're all developers, by the way. We all came from the development space. And that's actually one of my prerequisites before I hire a new developer advocate. They have to be a developer first, and then they have to prove to me that they know how to use the technology and they can explain it to me before we even start the hiring process.
Sure.
So when a developer comes and says, I love what you guys are doing, but man, this API is hard to use, you better believe that we're taking that back to core engineering and going, guys, this is what it should look like. How do we make it look like that? And to give you an idea is, if core engineering puts out an API that the community isn't excited about, then maybe it's our job to help with building some of those libraries and SDKs that lets them consume those APIs more seamlessly. Because there might be some really good reasons of why core engineering built it that way. I actually ran into that with a couple of phone calls ago that I had with core engineering where I saw the API and I was like, it seems really weird that you would do it in this fashion. And then they explained it to me and I was like, oh, that makes perfect sense why you did it in that fashion. But now I have to communicate that to the developer community. And instead of me just communicating it, why don't I just build a library that kind of abstracts it and presents it in a way that developers can get behind it? And so we'll be driving a lot of open source projects that are kind of in that vein of helping build the tools necessary to participate in the Hedera ecosystem, but also there to educate just on the core functionality so that developers who really want to get their hands dirty and really want to get down into the, lower level technology are welcome to.
Very cool. So maybe I'll ask another question and kind of focus it more towards the Dapp ecosystem and maybe
Sure.
even open it up beyond just blockchain and open up just to any really decentralized solution.
Mm-hmm.
You mentioned several things in your explanation earlier about telecom and supply chain. Realistically, what do you think the future of decentralized applications is?
It's definitely going to be a hybrid future. Sure. I know everybody wants to solve every problem with blockchain right now. And I personally have an aversion to that. And I hope I don't offend anybody in your audience. But when somebody says, I want to build this as a Dapp, my question is always, why? Like, what couldn't you have done on Firebase or using Cassandra or doing any of these other technologies that are just, quite frankly, because of the laws of physics, going to be faster?
Sure.
And if the question comes back to, well, I need the security or I don't have the trust layer that I need, now we're having a real conversation. But here's the cool thing about it. A lot of what we're doing with the Hedera is just going to enable people to build this, the public side of it, which is how do we interact with each other. But my prediction is that we're going to turn into this very hybrid world where there are going to be centralized servers and technologies. There are going to be private ledgers that interact with those centralized technologies. And then those private ledgers are going to interact with the public ledger. And we're going to do things like discovery and settlement and provenance and things like that on the public ledger, where trust is the important thing. Identity is one of the other big ones that you could have there. So I think what we're going to see is, for decentralized apps in particular, I'm going to say don't limit your vision down to what can I solve and not have servers. I think the right way to think about it is what can I solve that requires this level of trust or this trust layer that doesn't exist in a server layer or a clearinghouse model, for example. How can I build the public ledger in to create that trust layer? What are the components of my application that require that? And then what don't and can be solved by a private ledger, use a private ledger. Like, for example, Hashgraph, we've got a private ledger implementation that anybody can license and use for their private applications, even right now. And we're also looking at how do we build this out to be like a Hyperledger plugin so that we have kind of like a Hashgraph version of Hyperledger. So if you want all the tooling of Hyperledger, you could still have that and run a Hashgraph private network. And then at the same time, what things just work better on AWS or on local resources or on Google Cloud or wherever you're committed to. So I would say that the future of dApps is not going to be strictly public ledger dApps. It's really going to be a much more varied framework of how things interact with each other. Right now, people tend to think of, we've got client and server. I think we're going to go to like client, server, private network, public network, client.
Sure.
We're going to have all these strange architectures that are going to come out of it. And I think that's what we need to be thinking about is how do I get the most value out of all of these tools that I now have, knowing that even the public network and the private ledger have the sufficient security and throughput and fairness built into it. Those are the things to think about is what can I build with all of these tools now? Awesome.
Yeah, thanks for that explanation. I know there's lots of kind of varying viewpoints on that, but I appreciate you, expounding upon that. That's awesome. So, with this decentralized ecosystem kind of flourishing, maybe this this model where centralized systems and public ledgers and private ledgers can coexist. What if you had to put kind of a timeline on it where we start seeing big what do you think the adoption rate is going to be for this kind of thing? I guess is really my question.
January 2019. The only reason I say that is because at the end of the year we're launching our public network. And so we will now have we'll actually have a tool now that has the throughput and the security and the fairness. So that's a good thing. I'll tell you right now, there are lots of projects, and I say this because I'm in some of these working groups where they're trying to solve smart city initiatives. where they're trying to solve CDR reconciliation problems. So, I mean, I'm involved in a lot of these working groups where they already kind of have the architecture and they've already done the proof of concept. They just need the public ledger that is sufficient for what they are doing. So the projects are already there. So as far as timeline goes, I suspect that early 2019, we'll see a number of public projects come out. Actually, probably late 2018, we'll start seeing a lot of these projects start to really ramp up of real world practical distributed applications that we haven't seen yet. I mean, CryptoKitties was fun, but I don't know that that's really, world changing in the sense that it's going to have a huge value impact on, the social fabric.
Sure.
But it was fun, and it proved a concept, and also identified some of the challenges we had with the current Ethereum network. So I'd be happy for somebody to do CryptoKitties on Hedera. It wouldn't even make a blip, but it would be awesome to have something like that. Would be a really cool first prototype. And I think a lot of these projects already exist. We're talking to people who've run ICOs, people who have gotten VC funding who want to build on decentralized servers as well. A lot of great ideas out there. And I think towards the end of the year, we're going to see a lot of them come to fruition. Beginning of next year, we're going to start seeing a lot of these things really implemented. And I'd keep my eye on like the smart city space, and telco is one, supply chain is another one, IoT in general, even though that kind of fits into smart city initiatives as well. But IoT in general, we're going to see some cool stuff happen there.
Yeah, maybe can you elaborate a little bit on the smart city application?
Sure. Yeah. So I'm working on in a working group with the Telemanagement Forum, which is it's an organization that was designed to help telcos interoperate. And so they defined a lot of those standards of, how do they operate on the business level? And they're always trying to solve business problems. And every year they do these projects called catalysts, which are basically proofs of concepts of these various ideas. And this year we were involved in 3 of them. And by the way, we got involved with it before we even announced our public network. So we were just talking from the perspective of the private network. But once they saw the value of it in the public network as well, they were like, oh, yeah, we'd love to do that too. So here's just a use case on the smart city side. IoT is one of those things that's very noisy. There's lots of data being passed around.
Sure.
Probably doesn't make a whole lot of sense to have your consensus nodes on every IoT device, on every embedded device. I say just let your small little, single chip thermostat do what it's doing, but report its data to a hub. And so in our case, what we're saying is maybe every department has a number of sensors out there, whether it's traffic sensors or weather monitors or data about lighting, crime data. All of these things are being gathered, have the important summary stats be reported to the nodes, to the individual nodes per department. So imagine a private network where every department in the city has their own node or set of nodes, reports their data in kind of a filtered summary format into that. And now that data becomes available to the whole city without me having to integrate with each department's APIs or request, Excel spreadsheets or whatever, but have these things automatically being filtered into these nodes, and then have everybody in the city be able to start correlating that data to say, oh, we noticed that crime went down when we turned on the lights 5 minutes earlier. Right. Now, when you take all of that data and you run that into a city node or a set of city nodes, and every city is now part of its network. So you kind of have these concentric networks, right?
Right.
Each city's part of this, and now each city can start correlating data from other cities and their own data to come to some conclusions about it. So now what we've done is we've created this ability for cities to kind of self-optimize and report the results to other cities in a way that doesn't require anybody to really interact with each other. They're just reporting it in their own space and then listening to what the rest of the world is doing and how it affects everything else. So that's one component of it from a smart cities perspective. In that case, we've got summary data that's being transmitted through these nodes. We also can do things like device and asset management. So we know that when the city's traffic department, they know which IP and MAC addresses are associated with which private keys and which ones belong to which department or which section within the department or whatever. And the idea is that we can now prove that these devices belong to somebody and who they belong to. So when a fraudulent traffic device pops up on the network and starts reporting fraudulent traffic data, we go, oh, well, that doesn't match with anybody that I know.
Right.
That doesn't belong to anybody I know, so we're just going to ignore that. Or, oh, one of the things that I own has now fallen off the grid. Where did that go? Now we go inspect and find out somebody stole it off the street. whatever the case may be. But the idea here is we've got device and asset management now where we can prove who owns what, and the devices are meant to be on the network. This is big for network function virtualization and software-defined networks, which is big in the telco space.
Right.
Of like, when you've got all of these devices that are just on commodity hardware that just emulate whatever you needed to emulate at the time, it's really important to know who's doing that, who's spinning down and spinning up a new router, who's spinning down and spinning up a new sensor. It's important to know who's doing that and who they belong to, and that they have authority to be on the network and authority to report that information. So now we've got this, again, we're talking about trust again. This is the cool thing about what we're doing is we're adding the trust layer to the internet, which is really important. Now we take that a step further and we say, okay, imagine that you've got trash that needs to go out every week. And if you put your trash cans in the right spot, there's a sensor on the street and a sensor on your trash can. And when the trash man comes to pick it up, the trash collector comes to pick it up, he can scan it. And when he scans it and it shows that it's in the right spot on the street, you now get points for putting your trash out on time and in the right place. So it's in traffic, or it's not out at the wrong time, or out too long. There are lots of things they can start to figure out is, oh, did they bring their trash cans in within 24 hours instead of leaving it out on the street for a week?
Sure.
Things like that of like, how do we incentivize good citizens? And then we can start giving them citizen tokens. And now here comes the cool part is, so I'm in Montreal earning tokens as a citizen, putting my trash out on time, or maybe I'm walking by a trash can and scanning it with my phone as I throw trash away. So I get credit for picking up trash off the street or throwing trash away or whatever. I'm a good citizen. I showed up to the city hall meeting or something like that, and I get to scan on my way and I get citizen points for that. But whatever the case may be. And then I go on vacation to Paris, and they've got parking meters there that accept these smart citizen tokens. So now when we've got all these cities that are connected and I'm scanning in and being a good citizen in one city, I can leverage that to go enjoy myself in another city, paying for parking meters or getting access to city sponsored events or whatever the case may be. Or I can earn more citizen tokens there and come back and spend them at home. But this idea of how do we incentivize good citizen behavior, smart cities is more about just like optimizing the technology. It's also about encouraging good citizenship. So When I say smart cities, I talk about smart citizens as well. And if you think about that, what we had is at the department layer, we had a private network. At the city layer, we had a private network. And then we started rewarding citizens. We have a public network. So we've got 3 different layers of networks here. Each of them could be Hashgraph networks. You'd have the 2 private Hashgraph networks, and then Hedera is where you actually reward your citizens. And all of these can talk to each other automatically and automatically balance however it needs to balance. So that's what I meant by like, we need to just be aware that it's not just a public network solution and it's not just a private network solution. A real solution is one that scales. And in this case, there are certain cases where private makes more sense than public. And there are certain cases where public, and I would argue to say that like most cases, public is sufficient. But there are some scenarios where private just makes sense. And just to think about it that way, how do we build this private or this kind of hybrid world where private and public talk to each other, and we can leverage the new trust layer that didn't exist before in a trustless environment, if you will.
Awesome. That's a very elaborate picture that you've painted there. I really enjoyed that explanation. So, you mentioned a public net launch later this year. Is there anything else on the roadmap that you'd like for the people watching to know?
Well, so we are going to be launching test nets all summer, and we'll have multiple test nets. And so what I would say is, and by the way, we're also going to have a registration page. I know this is probably going to rub some people the wrong way of like, we are going to do KYC AML in the early testnet phases. We just want to make sure that until we have this trustless environment set up where everybody can operate in that trustless space, we do need to make sure that the people that are helping us build that and helping us test that and validate a lot of the things that we're building right now are in a trusted space. And right now, manual trust is what we have to go with, which is the KYC AML process. But as people do that, they're also going to have their dApps registered on kind of like a marketplace type approach. And we're building this. So this summer, we're going to be launching the test nets. I would say join the Discord channel. Also on the website, you can register your interest, and there are a few bullets there that might apply to developers. Mark those and send that in so that you get on our short list of people to invite to these test nets. It is going to be kind of controlled until we're completely sure that at scale we're ready to go. the math all makes sense, but until you actually implement and you start running servers, things always go wrong at that point. There's a whole bunch of unknowns. And so what we want to do is kind of vet all of that before we go to mainnet. We don't want to launch mainnet and have a bunch of surprises. Sure. But the algorithm, the math is sound, and we just have to make sure the technology backs up the math when it comes to actually getting into the field. The infrastructure stands up to the requirements. So we need people to help us test. We're going to need developers to help us test. We're going to need end users who want to participate in the test net. At some point, we're going to need people who just want to like have a wallet and transfer tokens back and forth or use dApps just to validate that, yes, everything is working the way we expected. We're going to need a lot of that. So I'd say between now, quite frankly, probably mid-summer, late summer, we'll be launching those test nets and start trickling people onto it. We have some private test nets running right now that are for specific clients that were engaging with us really early on, and those names are kind of already out. But so we've already got a couple test nets that are up right now that we're just doing some early stage development stuff on. And then we'll have the more robust test nets coming out later in the summer that we want people to just get on and participate and help us find everything that could possibly go wrong. Like if we find out that like in a month that this thing stands up to all the volume we're throwing at it, you know, maybe it does accelerate our mainnet a little bit. I would be very happy to see that happen.
Yeah, I like that. Very cool. So you mentioned the Discord channel and a place where people can sign up. So where would people sign up, and where would people learn more about Hashgraph or stay up to date with the things that you all are rolling out?
So the first place I would say is go to hashgraph.com, and probably safer to go to HederaHashgraph.com. If you go to HederaHashgraph.com, you can, at the top right-hand corner, there's a button you can click to register your interest, and you can fill out that form and tell us all about yourself and how you want to engage. And then what we'll do is we'll put you on a list, and we'll have account managers managing all of those interactions and making sure that those people who are in the developer space get the attention they need, and that we incorporate them into our queue of people that we're going to be introducing to the testnet at some point. At the bottom of that page, you'll see a number of links, icons, I should say, at the bottom of the page. And there is a Telegram channel that you can go to. That is our general Telegram channel that everybody's talking. There's also, if you go to that Telegram channel, you can also see that in the pinned message, there is a Hashgraph News Telegram channel you can go to. And that one gets pinged regularly. I mean, you'll probably get 2 or 3 announcements a day because we got so much going on. If you are a developer and you don't want to listen to all of that stuff, but you just want to stay focused on, what are the problems we're solving, and what are the technological challenges, and what are the more technical questions, then you can just go to hashgraph.com/Discord. If you look at the bottom of the main webpage, HederaHashgraph.com, you also see a little Discord icon. And when you see that, you can click on that, and that will take you into our channel. And then you can ask whatever developer-related question. I would warn you, though, if you're going into the developer channel asking when ICO, you're probably going to get some smart aleck answers. Not a lot of people take those, and you might not even get an answer at all. I think in the developer community, people are really trying to figure out how to solve real-world problems.
Sure.
Not to say that people who say when ICO are not trying to solve real-world problems. That's not the audience to talk to.
Sure.
And we sometimes get that, and it can be a little annoying sometimes. But if you're a legitimate investor, like, register your interest on the website and just go from there. If you're a developer, come join us in Discord channel and let's talk.
Very cool. Well, I appreciate you all, opening up your availability to everyone who wants to join the community like that. Well, Ken, I've enjoyed our chat today. Kind of before we wrap up here, is there anything else that you'd like for the people watching to know?
Not really. I think we covered all of the things that are coming up here. Really, I just like to reemphasize, we've got 6 developer advocates working around the clock who are available to answer questions, and some amazing community members that will answer any question you have. So if you're a developer building dApps and you have questions about how Hashgraph could answer that, or you've got questions just about the algorithm itself, come join the developer channel and feel free to ask there, because if it's not one of our amazing community members, it'll be one of the developer advocates that answers your question.
Awesome. That's a great resource. Well, yep. Ken, I've enjoyed our chat today. I'm sure everyone else has found this as educational as I have and enjoyable as I have. So everybody, go head over and check out Hashgraph. Check out all the resources that Ken has mentioned. And also be sure to subscribe to the channel to see more videos like this, where I'm talking to people like Ken, who are showing us new ways to build decentralized applications. And until then, thanks for watching Dapp University.